Welcome back everyone, we're going to be doing another exam video here on the channel. We are doing the 2024 Specialist Mathematics Paper 1, the QCAA Specialist Mathematics Paper 1 specifically. We may as well just jump straight into it with question 1, okay? Question 1 says, repeated random samples will be used to calculate a large number of 90% confidence intervals for a population mean U. I think it's actually pronounced mu, but whatever. Which statement best describes the possible outcomes? A. Approximately 90% of the confidence intervals will contain the population mean. Yes, that is exactly what that means. But we'll just check the other three. But right now, like, A is essentially the exact definition. B, more than 90% of the intervals will no. C is less than 90%, unlike. I mean, it could be, right? It could be more, it could be less. That's why the word approximately works really well, because it could be a little bit more, it could be a little bit less, but approximately 90% of the intervals will contain the population mean. Part D is exactly 90% of the intervals will contain the population mean. And again, it could, but that would be sort of like a fluke, like it's not guaranteed. So approximately is the word we're going to look for, and it was question A. So, a nice one to start, just some stats theory. If we come down here to question 2, we basically have the technique we use for integration using partial fractions. We just don't really have the integration part. We're just sort of given the partial fractions. So we need to know how to essentially get rid of the denominator algebraically in a question like this. So this is essentially algebra skill testing. To get rid of our denominator in a question like this, we can notice the largest denominator here is x multiplied by x minus 2. And we can see, I'll break it up into two different colors. I've got the x part, that's the same as my denominator for 3 over x. And I also have this part here, which is the minus 2 bit, which is the same as my denominator here for a over x minus 2. So when I notice there's this kind of common pattern within my denominators, I can simply multiply all of my numbers by, in this case, I'm going to multiply everything by x multiplied by x minus 2. So if I just write this out, I'll go sort of, I'll call it the long way, just to kind of show exactly why this works, in case people are still confused what I mean. We get x multiplied by x minus 2. So all I'm going to do is if I multiply every single term by x multiplied by x minus 2, I do the same thing here, x multiplied by x minus 2, and I do the same thing here, x multiplied by x minus 2, I get a series of terms that cancel out. My x minus 2 and my x minus 2 both cancel. My x and my x on the bottom both cancel, and in this case, my entire denominator and the entire thing I'm multiplying by is going to cancel out. With mathematics, as long as I multiply everything by the same number, it still balances, it still works. I'm not breaking maths. This is 100% legal to do. So what I wind up with is a multiplied by x, that's this little part here. I get plus 3 multiplied by x minus 2, that's the sort of the part remaining here. And my right hand side, and I'll scroll down a little bit so you can see, is simply just x minus 6. Now, all I need to do is find a way to solve for a, and to do that, I can substitute in any value I like for x. Again, as long as I put it in every single spot I have the letter x, then everything balances. If I can choose any number, the most logical choice is to choose the number 2. So if I choose the number 2, if I substitute in x equals 2, I pick 2 because if I look at my x term here, well, 2 minus 2 gives 0. So if I can ever create a 0 in my question, as long as my a is not the thing that gets cancelled out, it makes it very easy to solve. Again, but any number here, any number would work. I'm just picking 2 because it's going to make my life a little bit easier. So what I wind up with here is 2a. This is multiplied by, 3 times 0, so the whole thing's now gone. Okay, so I don't need to write that. Equal to 2 minus 6 is going to give negative 4. I can now divide both sides by 2. I'll scroll down. Sorry, the question's going to come off the screen a little bit. I can scroll down. If I divide both sides by 2, I get a equals negative 2. So my answer in question 2 is going to be B. Question 3, I want to consider the proof of the proposition. Okay, so this is like a sigma notation induction question. So I have from j equals 1 to n, brackets 2j minus 1, equal to n squared for all values of n that are positive integers. That's what this kind of symbol here on the end. For all values that are positive integers is basically more or less how to read that. This symbol here means element, but that's essentially how you could read something like that. That part of the end isn't super important. There was a question like this. Sorry, I've got a hair in my eye somehow. There was a question like this, I think, in the 2022 specialist tech free paper. Again, a sigma notation mathematical induction step. So we do need to be pretty good at how we can substitute into something like this. The particular step I'm looking at is for n equals k plus 1. That's written here. Okay, so I'm looking for this step here. Well, when I do this, all I do is wherever I have the letter n, which is in two spots, it's here and it's here, I'm going to replace it with k plus 1. If I do that, I wind up with, without looking at my options, and of course, you can just use this idea in your head, you could pick the correct bubble, but I would wind up with j equals 1 to k plus 1 outside of 2j minus 1 equal to k plus 1 squared. Okay, if I look at my options, or my bubbles, I guess step A and step B both have expanded k plus 1 squared. Part C and part D, I can eliminate both of these options immediately because I don't get k squared plus 1, I get k plus 1 all squared, which means I have to like FOIL bracket expansion. If I simplify the right hand side, I get k squared plus 2k plus 1. So that's sort of where this part here comes from. Okay, that's why A and B are the only real options I have available. If you look at part B, they put a k here where I have a letter J, so it can't be option B, it has to be option A for question 3. If we come down to question 4, question 4 says a plane contains the point 313 and is normal to the vector I plus j plus 2k. The vector equation for the plane is, well, a vector equation for a plane is r dot n equal to a dot n. I can write r, if we look at my options, right, all of these are in x, y, z mode. So I can write r as being x, y, z. I know n is normal to the plane. Well, my normal vector is given by the coefficients here. So if I do my coefficients here to create my column vector, I get 1, 1, 2. A is my point on the plane. That is going to be this point here. So 1, 3, 1. And again, I'm going to multiply that by the dot product of n, which is going to be, again, 1, 1, 2. And I should note, I can rule out C and D immediately again, because these are cross products. But to find the vector equation for a plane, I need dot products. So my options again are going to be A or B. If I look at both choices, my answer for question 4 is going to be B, because I have the incorrect vector here in part A. If we come across here, I've got question 5, and we're going at a really good pace here. Again, we have a minute and a half per multiple choice question, 15 minutes total to do the entire section of this paper. Again, I might take a little bit longer because I'm explaining, I'm doing things a little bit longer than I normally would. Question 5 is a Gaussian elimination, and I have had so many questions about how to do Gaussian elimination stuff, or that people really struggle. I think someone commented on a video previously that Gaussian elimination gave them PTSD. So these questions can be kind of scary when you look at them. There's so much information to process. However, if you get good at them, they're really nice marks. So we're given a Gaussian elimination question. We've got a little lower triangle here of zeros, which is great. And it wants me to specifically find the unique solution for the value of y. So if I'm trying to do that, I can look at my rows, and I can get my answer really fast. My bottom row, 0, 0, 3, if I write each of these out, right, this is basically 0x, if I write my bottom row is 0x plus 0y plus 3z is equal to 2. I can find z very easily, okay? My middle row is 0x plus 2y plus 0z is equal to 5. So I'm going to use my second row. I don't even need to know the solution of z. I can not worry at all about my bottom row because I don't need that information. I'm just trying to find the value of y. So I'll grab this, I'll pull this up just a little bit, okay? If I just want to find the value of y, well, I should know that 0 times x gives 0. 0 times y gives 0. So all I'm left with is solving a very simple linear equation of 2y equals 5. So y is simply going to equal 5 over 2, which gives me D as my answer in question 5. Let's come across here to question 6. I keep saying that, but apologies. If we look at question 6, I've got a dominance matrix question. In a dominance matrix, we assign 1 for a win, 0 for a loss. Now, if I just look at my dominance matrix here, I can already, without reading the question, place a 0 because Q can't play Q. Okay, this is like a fill in a missing row question, right? If I read my question, it says P defeats players Q and R. So if Q lost to P, I'm also going to put a 0 here, because when Q versed P, or when Q played P in whatever competition this was, Q lost, so I get 0 points for that. Q defeated 2 players, so I have to have 1s in the other 2 remaining boxes, but I will check the last little piece of information to see if that helps. Player R and S defeated 1 player each. I can see that R beat player S, which also makes sense that Q then beat player R, and S beat player P, so it also makes sense that Q beat player S. So therefore 0, 0, 1, 1 is correct, which means my completed matrix is, if I look through my options here, is going to be B as well. So question 7, again, I feel like we're really flying through this one compared to the others. Question 7, A, B, and C are points in 3-dimensional space. If 2AB equals BC, in other words, basically what that is saying is AB is twice the length of BC, but it has the exact same direction, okay? So it's heading the same direction as BC, but it's twice as long. So the magnitude of AB is twice the value of the magnitude of BC. That's interesting. That is very interesting, because I kind of did just sort of, oh wait, AB is twice the value. I guess that actually doesn't mean that. It's actually the opposite, right? I have to multiply. I kind of got that flipped up when I read the question out. Apologies. To get to the same length as BC, I need to multiply AB by 2. So let me just kind of re-explain that step. AB and BC are heading in the exact same direction, but to give AB the same length as BC, I have to multiply AB by 2. In other words, another way to write this is that AB, right, I can divide both sides by 2, is half the length of BC. If we have a look at it that way, we're scaling it by a half. So that means A actually is not correct. AB is not twice the value of BC. So apologies, I sort of read that out wrong originally as well. B, AB and BC are perpendicular. Nope. C, only one plane contain. No, that doesn't mean that at all. Like, it's possible, but no. So we got the option D, a straight line passes through A, B, and C. Well, the answer is yes to part D. This is also, there's a section on collinearity, so like points being collinear, and the proof is basically this idea. I said at the very beginning, AB and BC are heading in the exact same direction. So if they're heading in the exact same direction, then a straight line could pass through all 3 of those points. So my answer is going to be D. All right, let's look at question 8. Given Z equals 2 cis pi on 3, determine Z cubed. Oh, great question. Okay, this is just De Moivre's theorem. So I get Z cubed is equal to, I'll write the whole thing out, 2 cubed cis, which is the same thing as e to the I theta, in case you guys haven't seen cis notation. Same idea. Cis is going to be multiplied by, it's basically 3 times pi on 3, so it's just going to become pi inside my brackets. 2 cubed is going to give 8, so I'm left with 8 cis pi. Again, at this point, we can get our answer, we can circle our bubble. Just to explain where our answer is going to come from here, if I break up my cis notation into cosine, or r cosine theta plus r sine theta I wind up with 8 cosine theta plus 8 sine, oh, sorry, not theta. I kept saying theta, but I mean pi. 8 sine pi I. And I do put my I's after my signs. I know someone got upset with me about that as well, but apologies. That's just how I was taught. So, if we look at this, I know that cosine pi is -1. This is going to give -8. And I hopefully remember from the unit circle, sine of pi is 0. So I'm literally just left with -8, which means my answer is going to be 8. There's other ways to this too. We could do this on an Argand diagram as well. You have some choices, right? But I think expanding it doesn't take too long and isn't too abstract. Alright, last 2 questions. I feel like the 2024 paper 1 has been a little bit more straightforward than the previous paper 1 multiple choice sections. It's either that, or I'm just having a good night, I'm in good form, and things are just clicking. Things are just clicking really well. Okay, use a suitable double angle identity to determine the integral of 2 sine squared x dx. I will say, I don't think they need to specify using a double angle identity, because the technique to integrate something like this that we teach in methods is to use double angles. So if we remember the formula sheet, if we get the formula sheet up for specialist, and I feel like I have it just here. So I'll write it out exactly as you will see it if you look at your formula sheet for this question. One of my double angle identities looks like this. Cosine 2a is equal to, we have 1 minus 2 sine squared of a. So all I need to do is rearrange to make 2 sine squared a the subject. I'm going to do it the fast way, right? I wind up with this. I get 2 sine squared a is equal to 1 minus cos 2a. You could call this the old swippity swap. They basically swap spots. They literally just swap spots. That's not basically, that is exactly what happens. I'll zoom out so everyone can see the whole question. Apologies. So if I do this, that means instead of integrating 2 sine squared x, I'm instead going to be integrating 1 minus cosine of 2x with respect to x. So the integral of 1 is going to give x. The integral of negative cosine 2x, well, cos goes to positive sine when I'm integrating, so it's going to stay a negative. It's going to become negative 1/2 sine 2x plus c. And again, even, oh, sorry, that's cut off my face. Apologies. I'll zoom out a little bit more. Even if we've got the plus c, it's multiple choice. They all have plus c in them anyway. So I'm looking at my options. It is not going to be A. It is not going to be B. My answer is going to be C. Again, just kind of matching up the answer I've got with my different options. 1/2 sine 2x is the same thing as sine 2x all over 2. Okay, question 10. The final one. I almost did this in 15 minutes, even explaining everything. So again, I feel like this multiple choice section was kind of not too bad, right? Not too bad. So, question 10. The polynomial p of z equals z cubed minus 2i z squared plus z minus 2i can be expressed in factorized form as p of z equals to z minus I z squared plus b I z plus 2. Okay, where b where b is an element of z. Okay, cool. So, determine the value of b. We're basically just finding the value for b here. I know I'm saying I'm getting through this paper quick, and people like to point out, but you're a teacher, and that is true. So I guess I should get through it quick. I guess that does make sense. Okay, so if we have actually so many options, there's a lot of different techniques to factorize any polynomial, let alone complex ones. There is the idea of like an inspection method, okay, to factorize by inspection. If I know one of my factors is z minus I can essentially deductive reasoning figure out what that value for b must be. So if I expand everything, I get to z cubed minus 2i z squared plus z minus 2i. Okay, you could do that. I feel like if you've learned how to do it by intuition, basically, I think that's what it's called, the intuitive method, then either you're fine with this question and you maybe don't need too much help, or that method never really stuck and you just never know what to do because it's too hard and you can't do all the mental gymnastics. So I'm going to show a different way that is very reliable, where we use polynomial long division with a complex number to get to our solution. And again, I'm fully acknowledging there is a faster way, but I still think this is going to be very quick because we're trying to find the b term. So what this big ramble or big rant is to say is I can do polynomial long division where I do long division with z minus I, and I'm going to be dividing that by z cubed minus 2i z squared plus z minus 2i. And I feel like my handwriting is really messy today, so apologies. Let me fix this up real quick. I'm going to attempt to draw a straighter line. I had marginal success. So I'm going to look, I guess if you haven't learned polynomial long division, this isn't the method for you, but we're going to start by dividing our first two terms. I'm going to wind up with z squared here, which I should do, right? Because I know my first term here is z squared. If I do my long division, to clarify, I'm going to get this exact bracket, okay? So I do my first step, I get z squared. I can now multiply back in. I'm going to choose, I guess I'll choose pink for this color, because why not? If I multiply back in, z squared times z gives z cubed. Z squared times negative I gives minus I z squared. And now I'm going to be subtracting. I get z cubed minus z cubed is going to give 0. I have minus 2i z squared minus I z squared, so it's going to become plus. I basically wind up with minus 2i plus I. That is simply just going to give me negative iz squared. And I can bring down these terms, that's plus c minus 2i, but I'm actually finished, okay? I'm actually finished because if I now divide again, if I divide z by this term here, I simply wind up with negative iz, okay? This is the term in the middle. That is this term here. Or maybe I'll change my color, right? I'll use green. Oh, I'll use blue. This term here is this term here, which means b has to be negative 1. So my answer here is going to be C, negative 1. Okay, so that was actually very quick using long division. The pros of long division, whilst you have to learn how to do this whole dance, is that it's really, really consistent. It's not the fastest method, but no matter how hard the problem is, it always works for literally everything. It's not the easiest method to learn, but also once you learn it, there's no question that's really all that difficult, right? So I'd say it's very robust. You can do this on any question. It's no question's really harder than any other, and it's always like just a medium level of difficulty the whole way along, where inspection requires some mental juggling. And again, if you can do that, and you can see it's negative 1, then more power to you. You have the right answer. Okay, that is the multiple choice section. I hope you guys found that helpful. Again, please share with other people that do specialist maths, because you can help them out. They can then also help you if the way I explain it doesn't make sense. And also, it's good to have a community where we share and support each other on our, can be quite stressful journey of year 12. So, like I said, I hope you guys enjoy. Feel free to like. That really helps out the video a lot. For my 10 people that watch this, feel free to like. That'd be great. And I will see you guys in the next video. Goodbye, everyone.